Hi everyone, my name is Wongsathorn D. Korapkun. Welcome to this self-learn assignment presentation for my seminar course of the Software Engineering Kasetsart University. In this video, we are diving into a topic AI in cybersecurity, applications and performance evaluation. Over the next 15 minutes, I will walk you through how AI is transforming the world of cybersecurity and how we can measure its effectiveness. Let's jump in. So, why do we even need AI in cybersecurity? Well, cyber threats nowadays are evolving fast. Attacks like ransomware, phishing, and advanced persistent threats are more sophisticated than ever. The traditional methods like manual monitoring or static rule-based systems, they simply can't keep up with the speed and scale of modern attacks. That's where AI step in. It offers speed, scalability, and the ability to learn and adapt. So with AI, we can detect and respond to those threats in real time before they can cause us serious damage. So, what exactly is AI in the context of cybersecurity? In this video, we are mainly talking about three types. First, there's machine learning, which it learns from past attack data and detects patterns. Then we have deep learning, which is more advanced. It can process complex data like traffic patterns or even the malware code. And finally, natural language processing or NLP, which helps analyze things like phishing emails or suspicious communication. So these two form the AI toolbox for cybersecurity. Let's look at some real applications of AI in cybersecurity. The first one, AI is used for threat detection, where it identifies malware and anomalies in real time. Next is also be used in malware analysis to understand how new viruses behave, even if they have never seen those viruses before. Next is phishing detection. Phishing detection is another key area. AI looks at language patterns and links in emails to spot fake ones, to spot the fake emails. So next is behavior analytics. Behavior analytics monitors user behavior, spotting unusual activities can that could signal a threat. And and then we have intrusion detection systems. Intrusion detection this system can alert us to unauthorized access attempts. So all of these make AI a powerful ally in protecting our digital assets. Now, let's explore a real-world case study, Dark Trace AI. What is Dark Trace AI? Dark Trace is an AI cybersecurity platform that uses unsupervised learning. What's cool is that it doesn't rely on level data. Instead, it learns from from what's normal for a particular network and then identifies anything that looks out of place. This means it can detect unknown threats, things like traditional signature-based systems might miss. is a great example of AI adapting to each unique environment and still continuously learning. So take a look at this alert. So this alert is what triggered via a violation of one of the pre-packaged model breaches for device AT service schedule tasks. To try this specific alert, we need to answer some of the some following questions, like what were the triggers that causes the model to alert, or which host was the scheduled task created on, or were any files transferred, or is this activity commonly seen between those hosts? So by answering these questions, we can determine whether or not this alert is related to malicious activity. Here's a real example to make it more relatable. Imagine a phishing email that appears to come from a company's CEO, and it says like, please make an urgent payment to this account today. At the first glance, this this email might look legit, but the AI system flag it as a phishing email. Why? Because the writing style is slightly off, the IP address is unusual, and the sender's domain doesn't match the company's real domain. So all of this is picked up by AI using pattern recognition and contextual analysis. This is how AI helps catch sophisticated scams that can easily fool us humans. So what are the benefits of using AI in cybersecurity? So first, speed and efficiency. AI can analyze thousands of logs per second. Real-time response, it can stop attacks before they do any harms or before they occurs. Third, lower false positives. AI can reduce noise and focus on the real threats. And finally, 24/7 monitoring. The AI doesn't sleep, so they can keep monitoring all the time, making it ideal for a constant surveillance. These advantages make AI a game changer in keeping our system secure. But it's not all perfect, right? There are limitations and challenges too. The AI can suffer from data bias. If the training, if the data that's used for training the AI is have some mistake or flaw, the AI won't be accurate. So you have to use the accurate data. There are also adversarial AI. Adversarial means hackers also are using AI too to trick or evade detection systems. And over reliance, if analyze depends too much on AI, it might overlook threats that fall outside the AI scopes. And then there are privacy concerns. Sure, AI systems that monitor user behavior raise ethical questions. So you have the AI have to make sure that it's not going to steal the user data. So while AI is powerful, it's very powerful, but it's not a foolproof. Now let's talk about how we can evaluate the performance of AI in cybersecurity. There are several key metrics. First is detection rate, which measure how many real threats the AI is actually catches. And next is false positive rate. This means this tells us how often the safe activity or non-threat activity is being flagged or catched by the AI mistakes. Next is response time, or short is how fast the AI how the AI can react to the threats, and scalability, how will the system perform in large environment or unique environments. So let's say we have the three different models, AI models. We can create a comparison table showing which one has the best balance of detection, speed, and accuracy. So as you can see, model A have detection rate at 92%, false positive rate has 6%, average response time at 1.2 seconds. Model B, deep learning basis, detection rate at 96%, for false positive rate at 4%, and average response time at 0.9 seconds. And the last, model C, the hybrid AI, that mix the types of AIs together. Detection rate at 98%, false positive rate at 2%, average response time at 0.6 seconds. So we can see that the model C is the might be at here is the best out of three that can that have the highest detection rate and the lowest false positive rate. This means so it's it's, it's merely never do did a mistake and have a high is have a lowest average response time, so it means it's quickest in in this in this table. It means it's quickest to respond to those threats. So this kind of table or this kind of comparison is essential when deciding which AI tools to trust. Now you might be wondering, can I build a simple AI detector by myself? Yes, you can. With Python and libraries like Skit, I I don't know how to I don't know how to speak this, but it's Skit. I call Skit. Skitlearn, and you can with Python and libraries like Skitlearn, you can create a basic model. For example, train a classifier on email data like spam versus not spam. You can use algorithm like naive Bayes or decision trees, and with some level data, you will see how the model improves over time. It's a great way to understand how this system work under the hood, even if you are just starting out. This image shows a simple machine learning example using skitlearn's multinomial and multinomial NP classifier. Is a is a, this classifier is naive Bayes algorithm suitable for discrete features, often used in text classification. So this chart show the so this plot show the accuracy over training epochs. It demonstrates how accuracy improves as training process, eventually plateauing around around 0.98. 0.98. Looking ahead, the future of AI in cybersecurity is both exciting and a little scary. We are heading toward an AI versus AI world where attackers and defenders are also using intelligent systems. We will also see auto, autonomous security systems that require little or no human intervention. But with great power come comes with responsibility. We will have to deal with ethical considerations like how much monitoring is too much and how we protect privacy while staying secure. It's a future full of promise and complexity. To wrap things up, AI has enormous potential in cybersecurity. It improves speed, accuracy, and resilience, but it's not a magic solution. It has to be evaluated carefully and used responsibly. So the key takeaway, AI is a powerful tool, but it works best alongside human experts. Thank you for watching.